This is MATHguide.com, and my name is Mark Karadimos. In this video, you're going to see how it is you can approximate the area under a curve using left rectangles. We're going to use left rectangles as opposed to using right rectangles, using the midpoint of the rectangles, or the midline of the rectangles, or trapezoids. Those are all other legitimate strategies, and all are going to be done in other videos. Okay, let's take a look at a specific graph. So what I did is I graphed this function, and I graphed the function using a TI Inspire calculator. So I just plugged it in. I also put on the grid, so you can see that there's those little dots there. That kind of helps me draw some rectangles. You don't have to use a TI Inspire calculator. You could use a TI-83, TI-84. As long as you graph it and you put that function in, and I'm not sure if you're able to see that function as it's written there. So let me make a better picture for you. Yep, there you go. There's the function. Okay, so that's the function that I typed in there, and I've got a graph now. So I'm going to show you how to use this strategy. And specifically for this problem, we're going to find the area under the curve, not just for any old part of the curve, but we're going to go from -3 to 5. So let's say I wanted to find the area under the curve. So what does that mean? So in other words, from this section all the way over here, I want to find the area, that entire area under the curve all the way to the x-axis. Okay, so how do you do that? Well, what I'm going to do is use left rectangles. That means I'm going to go up to the curve until I hit the curve, and then I scoot over and make a rectangle. There you go. So, oops, except I didn't do this. I want to use rectangles that are 2 units across. Okay, now from this point, which is 2 units over, I'm going to go up until I hit the curve, move over 2 units. There you go. Now for this next rectangle, I go up till I hit the curve, and then I scoot over 2 units. Okay, again, I go up till I hit the curve, scoot over 2 units, and there you go. So what I'm going to do now is find the area of those rectangles. And of course, this will be an approximation for the curve. Now, is this a perfect approximation? No. Okay, you could see that I am not including this space. I am not including this, I shouldn't say space. I'm not including this area. I'm not including this area, but I'm including this area that I shouldn't. I'm including this area that I shouldn't. So, you know, is this a perfect answer? No. That's why I'm saying it's an approximation, and it's a legitimate strategy to begin with. Okay, so how do I find the area of a rectangle? Well, you take the length times the width. I'm not sure which one of these you want to call length and width, but you find the width of this rectangle, maybe times its height. Maybe that would be a better way to describe that rectangle. And I'm going to do that for all of them. Okay, so how do you do this? Well, let's see, the width is 2. Okay, so the area is approximately, so let's see, 2 is the width times the height. Okay, what's the height? Well, the height is going to be the function as it's evaluated at -1, 2, 3. All right, so in other words, the height right here, that is the y value of this point. Okay, so that point right there on the curve, you know, the distance from the x-axis to that point, that is the y value of that point, and that is f of -3. Okay, so that's the area of that rectangle. All right, what's the area of the next rectangle? It's going to be 2 times, let's see, the function is going to, well, let's see, what's the height of the rectangle? Well, it's the function evaluated at -1. How about the third rectangle? Well, it's still got a width of 2, but now the function is being evaluated at f of 1. And then finally, the last rectangle, 2, is the width, and it's evaluated here at 1, 2, 3. It looks like f of 3. Okay, so this is the area of all those rectangles individually, and obviously if you add up the areas of those rectangles, you'll get the approximate area under the curve. Okay, so how are we going to find this? Well, I could plug these x values into the curve, and I could evaluate this by hand. Take me a long time. So instead, what I'm going to do is I'm going to use a calculator, and I'll show you how to do that. So when I graph this function in the TI Inspire, I also created another document, and I hit the, I believe it's Control Document to add another page, and of course I added a calculator. Okay, so I'm basically going to click on that, and what I could do now is I could enter in whatever expression I want, and I'm going to put in that expression that we just saw a moment ago. Okay, so here I go. So how do I do this? Well, I'm going to press, let's see, 2 times, and now I want to pull up the function evaluated at -3. So how do you do that? You hit the var key, okay, and I'm going to show you a picture of the calculator there. So if you hit the var key, and you can see it pops up right there, and I can just press on this, and I can put in -3. Now, if you're using the TI-83, it's a little bit different. What do? You hit, I have mine available right here. So you hit, let's see. Oh yeah, it is the vars key again. So you hit vars key, the yvars tab, function, and then you could pick whichever you have typed into your graph. Usually it's the Y1. Okay, so it looks kind of like that. You see the Y1, just like that. Okay, anyway, that's how you do it with the TI-83, and I think the TI-84 works pretty similar to that. Okay, so let's move on. We'll put +2 times. Now I want to evaluate the function. I hit the var key or vars on the other calculator. Hit that, and now I want this evaluated at -1. See, you don't have to use the calculator, but using the calculator is nice, especially when you're evaluating functions at many intervals, especially like here where our width of our rectangles are 2. What if they're 1? What if they're a half? What if they're a quarter? What if we have a whole mess of rectangles? This is the preferred strategy. So I'm going to put in, let's see, 1, and then our last one would be 2 times y of 3. So I hit vars 3, and of course the calculator does all the calculation, and I get 38.4. So now I go over here and I go 38.4 units squared is the approximate area. And what I would suggest you do to get a better area is, instead of using a width of 2, use a width of 1. That means you're going to have double the number of rectangles, right? You're going to have 8 rectangles. Or use a width of a half. So instead of 4 rectangles, you have 16 rectangles. Okay, so the more narrow you make these rectangles, the more accurate you're going to be, and you can kind of see what area, the best approximate area you could get. Okay, so the more rectangles you use, the better. Please like this video. Please subscribe to the channel. Go to MATHguide.com for lessons, quizzes, and other instructional videos. We literally have hundreds available for you. Okay, so you can learn math. Just put your head down, learn in there, lean into those videos, check out the interactive quizzes to test yourself to see if you're doing this correctly. All right, have a great day.